Hi, everybody. Thanks for being part of Confling 21. My name is Spoons, or more formally Daniel Spoonhauer, but everybody calls me Spoons. I'm the chief architect at Lightstep, and you can find me at save_spoons on Twitter. Today, I'm going to talk about 6 ways configuration systems can fail. And this is, I admit, sort of a funny talk to give at Confling since, well, some of the failures do have to do with configuration languages. Many of them don't. And a number of them, I think, were ultimately related to thinking about configuration only as a language problem. So my ask for all of you today is to think about configuration a little more broadly. Why is configuration important? I was going to show some pictures of dashboards and say something about how production systems are really important and configuration is an important part of managing those production systems. But this happened on October 4th, a network configuration change was identified as the root cause of a multi-hour global outage for Facebook and its services. So I feel like maybe I don't have to argue quite so strongly for why it's important. But really, when I think about configuration, I think about it as a way of reifying how software is used, about encoding that use in a concrete way. And so as we're talking about important software systems, we're talking about how they're used, and we're talking about configuration as a way of again, making that use concrete. There's one caveat I want to put out, though, is that I'm really going to focus on the configuration of production software systems. So I'm not going to talk about other kinds of configuration like how you configure your IDE or things like that. Those are certainly important, but not areas where I have as much experience. And so the failures that I'm going to talk about, and in most cases, I think are more specific to production environments, but maybe they'll apply there as well. Maybe you all can tell me. Okay, I also want to say that I'm sharing my experience in this talk, and I want to share that in the spirit of a blameless postmortem. If you're not familiar with the concept, it's that we look back on our work and how that work affected others and try to be as critical as we can, but doing that without assigning blame. So what I'm going to say is not meant to be taken as it's my fault or it's so-and-so's fault. It's just that in hindsight, I think we could have done better. And I hope by sharing this that you'll have an opportunity to do better. Okay, how's this going to go? I'm going to talk about 6 ways that config systems can fail. Why 6? Because that's sort of what I could fit into this talk. I'm sure there's many others, so this is by no means exhaustive, but here we go. Okay, the first kind of failure is where there's a mismatch between what a component expects and what the configuration provides. So that could be the name of a field or its type or other invariants. And those mismatches lead to outages, the data leaks, or other bad behavior. When I say component here, I mean a software service or a piece of infrastructure like a router or a database, something that is configured, right? And so if I flip this around and state it more positively, I think the way I can say that is that configuration must be well typed according to the component that consumes it. So well typed, if that doesn't make sense to you, it's a little bit of programming language jargon, I feel like, but just that, as I said, that the configuration types and fields, they match what the software expects. So you can think of that as there's a schema and the configuration meets that schema. But I want to emphasize that it's really according to the component that's going to consume it. So it's not just enough that the configuration language is well typed, but those types really have to be consistent with how it's going to be consumed. So let me give an example of this. I'm going to use Kubernetes a couple of times. If you don't know Kubernetes well, it doesn't matter. It's just think of it as a job orchestration system. And one of the things that you can do is configure what's called a replica set. A replica set is a set of processes that all look like each other. It's a resource that you can configure in Kubernetes. One of the things that you can configure about a replica set is the number of replicas. And I've made a mistake here, which is that I've put a string in for the number of replicas instead of an integer. Now, helpfully, this will get caught by Kubernetes. So Kubernetes itself does some checking of the configuration before it applies those changes. So it'll refuse to apply this. And if there's an existing replica set, it won't be changed. And instead of creating a misbehaving one, it'll just refuse to do it. Now, another kind of configuration that you can specify, another resource that you can configure in Kubernetes is called a config map. And a config map is really just a vehicle or a channel for communicating configuration to one of the processes or one or more of the processes that's running within the cluster. So in this case, I'm configuring a config map for part of the application called a guestbook. And I've made a couple of mistakes here. One is I've put a O instead of a 0 in the port number. I've also misspelled database. I wrote datebase instead. Maybe it's hard to see in the slide. It was actually just, that's the way I typed it. And the issue here is that this configuration is well formed from Kubernetes point of view. It's a totally valid config map. It's just, I'm guessing that the application is not going to be super happy to get that config. So again, type check with respect to the component that will consume it. This shouldn't be considered valid config because it's not going to be interpreted properly by the guestbook application. And there's tools that do this today. My point here is more that we should think about configuration embedded with other configuration carefully, because I think almost by definition, configuration ends up crossing or maybe bridging across abstraction boundaries. So as you're thinking about building a system that passes configuration onto other components, maybe further down the stack, think about how that configuration will be validated and whether that validation is powerful enough to prevent these kinds of mistakes from happening. Okay, a second example of a failure mode I've seen in config systems is where we focus too much on measures of computability, and that distracts us from really understanding how the configuration language is going to be used, what's going to make it easy to be used, and how that language will integrate into the ecosystem itself. So again, maybe a more positive way of stating this is to say that configuration languages require IDE support, test frameworks, debuggers, everything that normal languages do, type checkers included, right? But I think what happens when we think about these limitations, and not to say that we shouldn't have some constraints or limitations on the configuration language, that's fine, but I don't think of them as necessarily helping us solve use cases better or make it easier to solve those use cases. So to give an example, here's a hard to understand program, at least hard to understand for me, written in a non-Turing complete language. Every regular expression I've ever seen used in production. Don't get me wrong, regular expressions are great ways of specifying a predicate, but they're a terrible way of communicating, at least communicating to me what you're trying to accomplish. So how do programmers like me learn and reason about new languages and the programs in them? Well, because there's familiar concepts in those new languages, because there's tools like type checkers or linters, autocomplete, IDE integrations, because there's examples and documentation or standard libraries that support that. But no one ever said, oh, it was easy to learn that language because every program can be proven to terminate. I know I built a language in which every configuration was proven to terminate, and no one said to me that made it easier to learn. And again, this is not to say that domain-specific languages don't have value or that configuration languages shouldn't have unique features. I think maybe a lot of the other things I'm going to say argue for some unique features. It's just you're not going to convince me that a language is easier to use because you put a novel feature in it. Again, show me how it improves the use of the language. Show me how it integrates better with the rest of the ecosystem. Okay. Shifting a little bit, but still talking about languages, a third way that I've seen configuration systems fail is where the language is used as the sole means of specification, including as part of an API. And when I've seen this, it's led to fragile automation, and it creates often significant maintenance problems for the maintainers of those configuration systems. Now, I said automation here. I'm going to say automation a bunch more times. Why is it so important? It's because there's a lot of repetitive work in managing these systems, and repetitive work is both boring, often unrewarding for people, and it's also a place where people can make mistakes. So thinking about automation as a important consumer of a configuration system is a thing I'm going to say many more times in the next few minutes. And it seems like maybe I shouldn't have to say API first in 2021. But I understand as language designers, we're putting cool features into our languages. So why wouldn't we want the automation to take advantage of that? And the thing is that automation is really a different kind of consumer, right? It's not trying to truly understand what's happening in the language. And in a lot of ways, it needs simple, atomic, easily composable units that can be put together that the tool author, that is the person who's writing the automation, can easily reason about. So configuration systems must allow components to be described with a narrow declarative API. Now, you might argue that maybe every system should be defined or should be able to be described with a narrow declarative API, but I think configuration is it's even more important for configuration. Here's maybe an illustration of that. One of the things I think that makes config different is that configuration is often the glue in building these larger systems, these amalgams, right? Where we take each of these individual software infrastructure pieces and we put them together. Configuration serves, again, as the connective sort of tissue in a way between them. And, maybe you imagine that you're sort of, up there at the top of the stack somewhere. I'm sorry to say that you're probably not at the top of the stack, or if your software is successful, you're not going to stay there for long, because just like this piece of software that was built and being maintained by someone thanklessly since 2003, like other people are going to build on top of that, and they're going to depend upon configuration as part of how they do that. So I said that this API should be narrow and declarative. What do I mean by narrow? I'm going to take a dig at a configuration system that I've used many times. I bet close to 100% of you have used it, whether you knew it or not. And I'm not going to stop using it either. The system I'm going to talk about is used to configure build tools. And I know this is not a production system, but the example I felt was too good not to use. And the way that you interface with that configuration system is through a configuration language, right? You specify a series of rules that you then provide to the tool, and then it carries out a sequence of actions based upon those rules and hopefully gets you to some desired state. This is not narrow. And what I mean by that is it takes a string, or maybe I guess a bunch of files, also a bunch of state of your file system, and also maybe a bunch of other stuff. And it does a bunch of things with that, right? And even if you want to think of that as sort of a sequence of strings, like that is a sequence of rules, those rules are deeply intertwined. Don't get me started on pattern rules, right? This is a really complicated thing that to think about as serving as a building block for building additional tools. But here's the thing, like that's what we've done, right? There are many systems that are built on top of Make, CMake and AutoConf, just to name a few, and they generate millions and millions of lines of configuration, probably configuration that no human hopefully ever has to read. I'm sorry if you do. But by thinking of the system as being configured solely through this language, we've made the job of those folks that maintain those tools, like CMake and AutoConf, way harder, right? Because they need to understand how all these things are going to work, and it's really difficult for them to, again, sort of build up from these small atomic composable pieces. I think we've probably also, made life hard for the maintainer as well. I've been in this position with a configuration tool, and I can tell you that maintaining a tool that was used both by humans and by other automation systems was really difficult, both because, as I'll talk about a bit in a few minutes, like they have different needs, but it was also really hard to make any changes because I had to go through and both educate users about the changes, make sure that the documentation was updated, that the users were trained, but I also had to go through all of the generated configuration and make sure that I wasn't changing what it was meant to do. But again, now I'm reading the output of this automation tool and trying to intuit sort of what the input was to understand what the intention really was and make sure that that intention is maintained in some way. I also said declarative. If you're a programming language geek like me, maybe you start thinking about Prolog. I don't mean that we should be configuring with Prolog. I mean, maybe we should, but I'm not arguing that we should be configuring with Prolog. What I mean is just that configuration should state the way you want things to be as the user, not the change you want to be made. So think of it like, I want there to be 5 VMs running and not add 1 more VM. This is really important for automation to work reliably in production systems. Things in production systems are breaking all the time. It's fine. It's normal. Even the automation itself is breaking all the time. That's sort of part of what it means in my mind to be a production system. But if something does break, including the automation, it's much easier to ask, are we running 5 VMs? Than it is to ask, did we add 1 more or not? Right? So if we understand what the final state is, it's much easier to figure out if we're there yet or not. And then we can make a plan from there. Now, that's not to say that some configuration won't appear to be a list of steps, but hopefully each of those steps corresponds to some verifiable state. And as I wrote here, it's fine, it's good, in fact, for the configuration to specify some constraints about how to reach that end state, right? So to give us some guidance about how the system should behave. That brings me to my next point. Configuration will be used to make incremental changes to production systems. And a lack of native support for incremental change will lead to significant manual work or fragile automation or both. What do I mean by incremental? Like, let's say I need to make a configuration change to 100 VMs that I'm managing. I need to be able to change the configuration for just one so that I can test and verify the change, and then maybe 5 or 10 more, and again, stop, verify, make sure everything looks good, and then maybe 30 or 40 more, and so on. This is a critical way of de-risking those changes. Now, you might be asking, can the configuration language itself help de-risk those changes? And absolutely, in some ways, yes. But a lot of the verification has to do with verifying the change in the production environment, in situ. And that's going to take more than just type checking. So configuration languages and APIs must allow for incremental changes to production systems. That incremental change is absolutely a necessity. But just to come back, why should configuration care about that? So as an operator, I could do exactly what I described, right? I could manually make the change to 1 VM and then 5 and so on. But I'll probably end up doing this a lot. Like every time I want to make a change to these VMs, I'm going to do that. So I really want some way of writing down this process. And really, to me, that is a way that when I talk about writing down a process for using a software system, that's about configuration, right? So I don't know, maybe this should have been part of number 3 instead of its own, but I feel like thinking about incremental changes is really important. So to make this concrete, let me go through another example. This is a system. I'm going to use Kubernetes again. I think we're actually, the authors have done a great job of thinking about incremental change and thinking about how to encode it within the configuration. So within Kubernetes, all you need to know is there's a thing called a pod. That's sort of the basic unit of compute. You can think of it like a process running somewhere. And as part of the configuration for a pod, you specify an image. You also specify what resources it needs, maybe some of the applications config, a few other things. And that's a resource that you can configure. In addition, you can also configure a resource called a deployment. And deployment is a resource in Kubernetes that manages many pods. So here I've specified that this one should manage 10 replicas. You'll see part of it sort of repeated or not repeated, but an embedded configuration here. In this case, these are both Kubernetes configs, so I don't have to worry too much about type checking because Kubernetes understands both of the resources here. But it's the same kind of specification that I would have given to an individual pod. And then I've also specified a constraint on how those changes are made. I've specified that strategy called a rolling update. So this is, again, another resource I can configure. I can use the same configuration tools to configure both of these things. Almost the same APIs. Of course, the types are different and the behavior of the resources is different. But the thing that I think is cool about this is that both the base unit, that is the pod, and the controller, that is the deployment, are both separately configurable entities. Now, I don't recommend trying to manually configure the pods that are also being controlled by the deployment. That's obviously going to go terribly wrong. But the point is, if I already understand the pod actually is the same unit that is going to be controlled by the deployment. And so it's a unit for building something like a deployment and for understanding the behavior of that deployment. And deployments are one of many ways that you can manage sets of pods. In fact, you as a user of Kubernetes can customize and build your own controllers as well. And the reason that works is that there's a bunch of stuff that I've not shown here. There's a way of naming these resources, of describing collections of those resources, of specifying access control and how those resources are created or changed. There's ways of managing state for something like a deployment controller. So there's a whole bunch of pieces that went into this sort of ecosystem that made this kind of incremental configuration possible. And again, this is sort of what I'm asking you to think about, that what are those pieces and how will they be satisfied? Naming alone, I feel like we could talk forever about, right? Okay. Number 5, unlike code, configuration isn't finished when it's compiled. Not having both the source and the output at critical moments can lead to outages or even extend the duration of outages by hindering communication. Now, I know that, of course, when you compile a binary, you produce debug symbols or things that can be helpful to a debugger. That's true, but I think there's something different about the way that configuration is used, and the way that the source and the output play a critical role in a range of different processes from development to production. So to illustrate this, let me kind of talk through the life of configuration. So configuration might start when it's written for maybe a new feature, a new component. So as a developer is developing that component, they write some configuration. And when they submit it to the build pipeline or to an integration test, they provide that configuration as well. So it's transmitted at that point. It's read by those tests maybe, or by the build pipeline. When or if it goes out to production, that might be approved as part of a change request. So there's a human that might be looking at that configuration to make sure that it's appropriate and it's what we want to submit to production. Once that's approved, the configuration will be copied, probably to some sort of replicated storage, or at least some sort of probably highly available storage, at least as available as the application is configuring, right? Because most components that don't have their configuration are not going to perform well. So we want it to be available there. But maybe it's read by an automation tool because, of course, we want to make incremental changes to production. So as it's read and then again written by that automation tool, it'll then be read by other parts of the production system. And maybe in this case, that configuration is part of an incident that occurred. And so the configuration will be read by people both responding to the incident in the moment and by people following up in a postmortem and trying to understand what happened there. And if that's the case, maybe a new version of the configuration is going to be written by a developer. So, I wanted to call out a bunch of things here. Where the config is stored is really important, and that actually differs at different points in the process. So it might be stored with the code as I'm writing it, maybe at the end too, because we want to have version control and think about the history of the configuration. But it needs to be stored in the build pipeline in some way as well, so that it's available for testing. Maybe as part of the documentation or as part of a change request, and as part of the production systems itself, right? It needs to be stored there. So that it can be read and written by systems that are running in production. So it's stored in lots of places and it's consumed by lots of different people and processes, and even in an interleaved way, right? It's not as though it's purely used by humans and then we're pass it off to the software to do things. It actually goes back and forth several times between those. And one thing is that maybe the comments in that configuration are important to the humans, probably to this change manager who's trying to approve this request, probably to the incident responders. But hopefully the comments don't matter to the software. So, whether or not those are maintained, how those are maintained. And this gets actually even trickier when you think about how configuration is embedded, how it's transmitted through these components, whether or not we can preserve some of those comments or other documentation that helps the humans understand the intent there. And thinking about all these different people involved and the different use cases leads me to my last way that configuration can fail. Configuration systems that are designed only for developers will fail to meet the needs of operators. Those designed only for operators will fail to meet the needs of developers. Those designed only for humans will fail to meet the needs of automation, and those designed only for automation will fail to meet the needs of humans. Configuration systems must be designed for the competing needs of these different users, right? I hinted at this already, that there's a lot of different users, developers, change managers, SRE operators, as well as automation. But I want to take that one step further and say that those users actually have competing needs, right? That we have to understand the trade-offs involved here. So let me talk through some of those examples. So as a developer, I want configuration to be easy to share, right? I don't want to have to coordinate with all the other people on my team, with people on other teams every time I create a new piece of configuration. I want them just to get a version of it that works for them. They shouldn't have to think about it. I also, as part of sharing it, I want to make it easy to write. So I want to reduce keystrokes. That saves me time, probably saves them time too if they have to read it. And it also, maybe I want to share configuration across my team. Maybe I want to share configuration across different environments where that makes sense. And that's also a way of reducing keystrokes and maybe making the intent more clear. I also want to make it easy to edit configuration. And that means making the semantics both of the language clear and also the semantics of the resources that are being configured. So what does a pod mean? What does a deployment mean? We also need to make sure that we're providing some bulk editing mechanisms so that we can build tools. Just like we refactor code, we're going to have to refactor configuration. As we think about the life cycle of configuration, we're going to have to think about how we manage it. Maybe we're sunsetting a feature, we need to sunset the configuration as well, and finding all the places that configuration exists and maybe removing it is not a task that we want to do manually. So thinking about how to do that in bulk is important. And these, thinking about sharing and editing, kind of thinking about configuration in the large, maybe, right? I'm thinking about it as sort of an expansive way. But it's also important to isolate pieces of that configuration. So we might want to restrict who can change some parts of the configuration, or even who can see some parts of the configuration if it has some particularly sensitive information in it. We want to be able to identify risky configuration and identify configuration that's not so risky. And maybe that's even two parts of configuring the same component, right? So figuring out how to divide it is important. We want to make it easy to deploy changes to configuration. We want to be able to couple configuration with other changes. So as I roll out a new binary, I want new config to go with that too, because hey, guess what? That configuration expects there to be some new configuration parameters that I just added. And also just maybe I want to make fewer changes to production. And if I can and bundle these things, that makes it easier. But at the same time, I also want to make it easy to roll back changes and to roll back the changes in a really precise way. So we have to make it easy to identify what changed, as well as who changed it and why. Or maybe there was more than one person involved and it was a series of decisions and actions that led to that change. So thinking about the sort of provenance also of this information and providing means to change it in narrow and then, like I said, precise ways. So again, if I think of this from a developer point of view, I might take one perspective on things. If I think of it from an operator point of view, I might take a different one. If I'm taking a point of view from a tool builder, I might have some different requirements. And like I said, I'm not sure that there's one answer to these things. My experience is that there's just conflicts between those needs, and how you solve it is going to depend upon who's in your organization and what the processes you have are, what the needs are. It might be that you've strongly divided responsibility for development from operations and you use different sets of tools. Maybe that configuration needs to account for that. Maybe you're a DevOps shop and you have combined responsibility for those things. That could lead you down a different path and a different set of tools, a different way of thinking about configuration. So to sum up, I kind of wanted to, I've talked about 6 ways configuration can fail, and I kind of wanted to give you some themes that I think sort of flowed through that. So one of those is that configuration languages are part of the solution, but I think they're just part. And I want to encourage all of you to think about APIs, about tooling and automation, other pieces of these ecosystems that are used. I think we should actually have a high bar to introducing new configuration when we're thinking about these systems as a whole, both the software and the configuration. When we're adding new complexity, think about where's the best place to put that complexity. Sometimes it might be part of the code itself. Maybe at other times it's the config. So I think, again, we want to have a high bar to introducing new kinds of configuration. And I think we also should have a high bar for building new tools specifically for configuration. I'm not saying I know exactly how to do this, but I think what I've described today is a set of requirements for these configuration systems. In production systems, describing, managing, and understanding change is super, super important. Change is both necessary and risky. Change is how we make progress, right, by moving forward. But change is also when things most commonly go wrong. And so our configuration systems really need to think about change as kind of a first-class concept and make sure that that's something that both humans and automation systems can leverage in a tool in managing these systems. And then finally, I talked about how configuration has many different users, many different producers and consumers, and each of these have different needs and are, have different tools and ways of thinking about the configuration. So think about the socio-technical systems around the configuration. Think about the structure of your organization, responsibilities in your organization, processes in your organization, and in who the stakeholders are for configuration. Think about the risks and challenges of those different pieces of the organization, and think about how configuration can maybe mitigate some of those risks and challenges, and think about where it might actually amplify them and use that as a sort of yardstick in thinking about how you're building and designing configuration systems. So with that, I wanted to thank you all for watching. We'll be doing live questions on Monday, October 18th. So I'll be there in the experience report session. That's between about noon and 1 p.m. Pacific time. I'll see you there. In the meantime, you can find me at save_spoons on Twitter. Again, my name is Spoons, and it was great to share this with you, and look forward to talking to you soon. Thanks.